Good morning, my YouTube viewers. What we're going to do in this video is we're going to create a normal distribution. And the reason why we're going to create a normal distribution is because in the previous 4 videos, we were talking about a symmetrical distribution, a left skewed distribution, and a right skewed distribution. So now what we're going to do is we're going to create some distributions that are going to be used in hypothesis testing. And it's certainly not all of the distributions, but it's some. And then basically what a normal distribution is, it is a symmetrical distribution. Sometimes it's called a Gaussian distribution. Sometimes it's called a bell curve. And sometimes it's called a Z distribution. And those are all names for the normal distribution. So what we're going to do is we're going to write a program in Python to actually create a normal distribution. But before we do that, what we have to do is we have to import some libraries. So the libraries that we're going to import are numpy SMP. And numpy is a numeric library that creates numpy arrays, it creates distributions, and it also performs numeric computations. And then we're going to import matplotlib.pyplot_splt, which is a visualization library that helps us to visualize the distribution that we have created. So after we have imported our libraries, what we're going to do is we're going to set up the parameters for a normal distribution. So the mean is 0, and that's the center of the distribution. Standard deviation is 1, and that's spread of the distribution. And size is 1,000, so that's the sample size. So now we're going to generate the normal distribution using numpy. So data equals np.random.normal, indicating it's a normal distribution. Brackets, log equals mean, comma, scale equals standard deviation, comma, size equals size. And then after we have created the normal distribution, what we're going to do is we're going to use matplotlib to plot it. So plt.figure, brackets, fig size equals 6, 4, and then plt.hist, which means we're making a histogram, brackets, data, comma, bins equals 30, comma, density equals true, comma, color equals sky blue, comma, alpha equals 0.7, comma, edge color equals black, comma, and the label is data histogram. And now what we're going to do is we're going to overlay a theoretical normal distribution curve over the distribution that we have created. So x equals np.linespace, brackets, mean minus 4 times standard deviation, comma, mean plus 4 times standard deviation, comma, 1,000. So the 1,000 means it's 1,000 points. Y equals, brackets, 1 divided, brackets, np dot square root, square brackets, 2 times np dot pi, brackets, times standard deviation, brackets, brackets, times np dot exponent, brackets, negative 0.5 times brackets, brackets x minus mean, brackets, divided by standard deviation, brackets, to the power of 2. And then we're going to plot this curve on top of the distribution. It's going to be overlaid on it. So plt.plot, brackets, x, comma, y, comma, color equals red, comma, line width equals 2, comma, label equals normal distribution curve. So we're going to customize the plot. The title is going to be normal distribution with a font size of 16. X label is value with a font size of 12. Y label is density with a font size of 12. And then you get a legend with a font size of 10. And then you get a grid with an alpha of 0.3. So we're going to show our plot and type plt.show. So this is the normal distribution that we have created. So you can see the normal distribution curve is overlaid on the data histogram, and you can see that the data histogram it looks close to a normal distribution, and that's basically what we wanted to create. So this concludes the video on the normal distribution. The next video we will be discussing another distribution, and I hope that you decide to watch it.